In this segment, we're going to talk about laptop memory. Now, first we'll go over some historical memory examples to kind of see how far things have come. Then we'll go over the types of memory used in a modern laptop system, and then we'll see how you can actually install or upgrade memory in a laptop system. Now, as far as historical memory examples, back in the old days, laptops were even more proprietary in nature than they are today. And that proprietary nature extended to the type of memory that the laptop would use. What that meant was that if you had, say, an IBM laptop, you had to buy IBM brand memory. If you had a Compaq laptop, you had to buy Compaq brand memory. Each company made memory that was in a specific non-standard form factor that would only work in their systems. That meant that memory was expensive, you could only buy it from the manufacturer of the laptop that you purchased, and there were very limited capacities available. You couldn't add as much as you wanted, perhaps. Here's an example, in fact, of one of the older proprietary memory modules. Uses non-standard connectors, has a non-standard size and shape, and would only work in this case, a Compaq that it was designed for. Modules like this were often also very low in capacity compared to modules today. This module, for example, only holds 16 megabytes of memory. Now, typically, this type of memory was used on laptops that were with 486 and older processors. So really, systems from the 80s into the very early 90s. Now, in an effort to have industry standard memory for laptops, an organization formed called the PCMCIA, the Personal Computer Memory Card International Association. And this group, which we now know well today as sort of the originator of the PC card, this group founded to design cards that really were for memory upgrades. I mean, today we have PC cards that are network cards, wireless and wired network cards. We have SCSI adapters. We have video capture cards, sound cards, all kinds of cards that can plug into a laptop through the PCMCIA or PC card slot. But originally, that slot or socket was designed for memory cards. Now, here's an example of a PC card or PCMCIA memory card. Now, this one happens to be a flash memory card, but back when these first came out, they were often just DRAM memory cards, often in the capacity of anywhere from like 2 megabytes to up to 16 megabytes. They were expensive, and back then when they were used as memory cards, you didn't insert them into an open slot on the side of the system. You actually opened up a cover and put them inside the system and then closed the cover, so they weren't externally accessible. Well, the PCMCIA slot went from being a memory slot to something completely else. It became a sort of a universal expansion slot for laptop systems that allowed all sorts of upgrades other than memory. In fact, the memory aspect of it proved to be not effective because the interface was simply too slow. It couldn't keep pace with the increasing performance of systems. It was designed for systems that were like 10 megahertz in speed, not hundreds of megahertz or gigahertz as we have today. So what do we use for modern laptop memory? Well, modern laptops use mainly 3 types of memory. We have what's called SDRAM, which stands for Synchronous Dynamic RAM. We have DDR SDRAM, and the DDR stands for double data rate, and just as the name implies, it's twice as fast. And then we have a newer type of double data rate called DDR2, which has simply added some extra integrity to the signals in order to allow even faster speeds. So let's take a look at these different types of memory and see what they stand for and how they work, and then we'll look at the types of modules that they come in. Well, SDRAM, synchronous dynamic RAM, the S is for synchronous, and what that meant was this was the first kind of memory that ran at the same speed as the motherboard in the system, or more accurately I should say ran in sync or in synchronization with the speed of the processor bus. So this was the first type of memory that we had that could really keep up with the processor. And as you had different processor bus speeds, you had to have different memory speeds, SDRAM memory speeds, to match. The 3 most common speeds we had for SDRAM was 66 megahertz, and we often abbreviated that or called that PC66 memory. And then we had 100 megahertz, or PC100, and finally we had 133 megahertz, or PC133. And this was in sync with the speed of the processor bus. So even though processors were running, for example, up to a gigahertz, the processor bus was still running at the lower speed of, let's say, 100 to 133 megahertz. Now, PC 100 and 133 memory, for example, was commonly used on systems that had Pentium 1, 2, or 3 processors, as well as the AMD Athlon processor. Those systems commonly used up to the PC 133 type memory. Next came even faster systems, and we required even faster memory. So the next advance was to something called DDR, double data rate. As the name implies, instead of transferring 1 time per clock cycle, DDR transfers 2 times per clock cycle. It transfers on the rising and trailing edge of the clock signal, so 2 times per clock cycle. So if the actual clock cycle was at 100 megahertz, the DDR would run it as if it was running at 200 megahertz. So there's some confusion there sometimes. Sometimes somebody will talk about the actual clock speed, and in other times they'll talk about the effective clock speed, and the effective clock speed, of course, being twice what the actual clock speed is. Normally we talk about the effective clock speed, since that's really kind of what it seems to run at. It doesn't really matter what the actual clock signal is. If it acts like it's running at 200 megahertz, then by gosh, it is. Now, the DDR memory started out at the 200 megahertz effective rate, and we went up from there. Now, another way to talk about speed of memory is not just in megahertz or millions of cycles per second. A better way to talk about the speed of memory is the throughput of the memory. That's how fast data can be moved from one end of the bus or into or out of the memory module. Now, in order to talk about throughput, we have to know about the width. All of the modern memory modules that we use are 8 bytes wide or 64 bits wide. Now, what that means is, for example, if you have a module that's cycling at 200 megahertz, 200 million cycles per second, and every one of those cycles it can transfer 8 bytes, that's 200 times 8, or 1,600 megabytes per second. That's what we would say is the throughput of that module. So that's why, when talking about DDR memory, they decided to sort of de-emphasize talking about the pure clock speed, because that's not as meaningful as talking about the throughput. So 200 megahertz DDR memory was also called PC 1600, with the 1600 being the throughput in megabytes per second. And speeds went up from there. For example, the next speed grade we had was 266 megahertz DDR memory, which if you did 266 times 8, you'd have a 2133 megabytes per second. And we just simply abbreviated that as PC 2100. So if your system ran at the 266 megahertz memory bus speed, effective that is, then you needed to put in the PC 2100 speed module. The next speed up from there was PC 2700, and that was running at 333 megahertz effective speed. So again, 333 times 8, we got 2667, which we simply abbreviated as PC 2700. And then finally, sort of the top-end speed grade of the DDR memory was the PC 3200 module, which was an effective clock speed of 400 megahertz. And again, 400 times 8, you get 3,200 megabytes per second, and that's how fast data can move in and out of these modules. Now, what was discovered was that when you hit that 400 megahertz speed, or 3,200 megabytes per second, going past that was difficult to maintain signal integrity. So the engineers came up with a newer type of memory called DDR2, which was basically an improved version of the DDR memory. And what this did was use differential signaling, which means there was like a push-pull pair of wires for each signal. And by doing that, we had greater integrity, less chance for noise or crosstalk between the signals. With DDR2, we started out at the 400 megahertz effective clock speed and go up from there. For example, currently we have the 400 megahertz speed, which is called DDR2 400, or in the module form it's called PC2 3200. And then we also have a 533 megahertz effective version, which is PC2 4200, and that's currently the top end of the DDR2 memory used in laptops anyway. Now, only the newest laptops use the DDR2 modules. Many laptops on the market today still use the DDR memory, and really only obsolete systems anymore would use the regular single data rate, or just what we call SDRAM, the PC133. So now we've talked about the three different kinds of memory as far as the types: the regular SDRAM, the DDR or double data rate, and the newer DDR2. Now let's talk about the types of modules that they come in. Now, SDRAM came in a module known as a SODIMM, which stands for Small Outline Dual Inline Memory Module, SODIMM. And this one had 144 pins on it, so we called it a 144-pin SODIMM. Now, these modules had a unique pin spacing and a notch that was offset to one side so that you couldn't put them in backwards. There was only one way that they would fit in the socket in the system. Now, of course, there were different speed grades available, so just because the module would fit in a particular machine doesn't mean it would necessarily work or even be recommended for that machine. For example, if your machine required a PC133 module, you couldn't or shouldn't put in a PC100 module. There's a small ROM on the module that the motherboard will read to determine the actual speed of the module. And if it reads that it's only 100 megahertz and it requires a 133 to keep up with the processor, the system will A, either just shut down and not boot up, B, possibly display an error message, or C, actually drop the speed of the processor bus to match, effectively slowing down the entire system. Neither of those results is really what you're looking for. So make sure when you're installing memory, no matter what type it is, that that memory meets the minimum requirement for the system, that it meets the minimum speed requirements. Now, one thing you could almost always do is install faster memory than what's required. For example, if your system required DDR memory that was rated at PC 2100, you could instead install the PC 2700 or PC 3200 module instead. It wouldn't improve the performance of your system really, but the faster memory will almost always happily slow down to the lower speeds. Now, why would somebody buy the faster memory if it was not going to run at the faster rate? Well, good question. If that faster memory cost a lot more, then that certainly wouldn't be recommended because you're not going to get any benefit out of it. But what if it cost about the same? What if you could buy a PC 3200 module for about the same price as a PC 2100 module? Well, I'd buy the 3200 module then because it would work in a system that would require the PC 2100 module. But yet, if I ever decided to remove that module and install it in another system, for example, let's say I was going to sell one of my laptops and I don't want to sell it with all the memory I put in it. If I had upgraded it extensively, I might take some of that memory out and want to use it in one of my current systems. And if I had overbought the speed of the module, if I had bought like a 3200 speed module instead of a 2100, I might be able to use it in a newer machine. So I weigh that out when I'm buying it. If the price of the faster module is about the same or only a little bit more, I might spend the money to get that faster module just because I might have some future insurance in that I'll be able to use that module in another system in the future. Of course, if there's an excessive price difference, then I generally don't recommend that because if you never did put it in another system to take advantage of the extra speed capability, you'd be really just wasting your money. So now let's talk about the DDR modules. Now, DDR modules like this one are also called a SODIMM, Small Outline Dual Inline Memory Module, but these have 200 pins and the notch is at a different position. So even though this module is about the same size as the other module, they won't go in the same socket. So in other words, you couldn't put a DDR module in place of a regular SDRAM in a regular SDRAM socket or vice versa. It simply won't fit, the notches won't line up, even though the modules are about the same size. Now, what I don't have here is one of the newest DDR2 modules. They are also 200 pins and are the same size as the DDR module, so one would think, well, they might be accidentally interchangeable. But no, they, of course, thought ahead and made sure that the notch was in a completely different position so that there's no way to put a DDR2 module in a regular DDR socket or vice versa. So there's no way to mix those up. which is good because they run at different voltages and such, and if you couldn't manage to get it in there, you'd possibly fry it as soon as you turn the system on. Now, let's talk about these speed grades again and how that's computed. Remember, the width of these modules is 8 bytes, or, well, 64 bits, but it's easier to say 8 bytes. So each cycle that you transfer data into or out of these modules, you're transferring 8 bytes. And if, for example, I have a module that transfers at 400 megahertz, that's 400 million cycles per second, I can multiply that 400 million times a second, it's going to transfer 8 bytes. So if I go 400 times 8, I get the 3,200 megabytes per second is the actual throughput speed on the module. And that's typically how the modules are sold. So modules are sold by their throughput speed. A 400 megahertz DDR module will be labeled PC3200. Same thing with a 400 megahertz DDR2 module will be called PC2 3200. A 533 megahertz DDR2 module will be called PC2 4200 because we take the 533 megahertz and multiply that by 8, and we get 4266, which the megabytes per second, which they simply abbreviate as PC2 4200. So that's how these numbers are used, to talk about the speeds of the module. Now, there's one other number that's used when we talk about the speed of a module, and that's something called the CAS rating, or column address strobe latency. Now, it's sometimes abbreviated just CAS, sometimes it's CASL, or sometimes just CL, column address strobe latency. And latency basically means a delay. And what this is a delay in the number of cycles during one phase of a burst memory transfer. So the lower that number would be, the better. For example, if you had a choice between a module that had a CAS or a CL rating of 2.5 or 2, you would take the one that was rated 2. That would be better. It would be shaving a half of a cycle off of every memory transfer. Now, these minor differences in CL or CAS ratings don't really affect system performance that great. I mean, you would need a stopwatch down to the accuracy of a second timing a benchmark in order to see any difference. We're talking very small percentage differences here. But if, for about the same money, I could have one with the lower CAS or CL rating, I'll take it. So definitely look at that when you go to buy memory. For example, if you're going to buy PC 3200 DDR modules, look and see. You'll see them with CL ratings of 2.5 and maybe 2. And if they're about the same price, you might go for the ones that are rated the lower 2 number, which would be a little bit faster. So take a look at that. That's one other item that has to do with the speed of the memory performance. Well, we've taken a look at the different types of memory that can go in a modern laptop. 3 main kinds. Remember, we have SDRAM, we have DDR, and DDR2. Let's talk about upgrading the memory in a laptop. Now, a lot of times I end up discouraging memory upgrades for several reasons. Number one, if your system doesn't use one of those 3 types, that is, if it doesn't use SDRAM, DDR, or DDR2, then it's probably too old to be upgrading. For example, if it's a very old system, it might use something called fast page mode or EDO, extended data out memory. That type of memory is extremely obsolete, which makes it more expensive, difficult to find, and really not worth purchasing. It's even questionable to be upgrading systems that use the PC133 memory these days. In fact, you'll find PC133 memory costs about double that of the DDR or DDR2 for the same amount. So, for example, if you buy a 256 megabyte PC133 module, you could, for the same money, probably get a 512 meg DDR or DDR2 module. So, again, buying obsolete memory is more expensive than buying newer, faster, better, state-of-the-art memory. Of course, you can only put in your system what your system will support. Now, how much memory should you have in a system? Well, I tend to think of PCs in terms of, not just the hardware, but also the software that they're going to run. And generally, I'm running PCs with one of two main operating systems. I either run Windows 98 Second Edition on a system, or I run Windows XP. Of course, any system that is capable of supporting Windows XP, that's what I'll run. But if it's an older system not capable of running Windows XP, then I'll run generally Windows 98 Second Edition. Now, that operating system requires a minimum of 24 megabytes of RAM, preferably 32, and really works best with about up to 64 megabytes. So if I have an old laptop that I'm going to be using to run Windows 98 Second Edition, I might see if I could upgrade that to about 64 megs of RAM. Going past 64 megabytes generally isn't going to be that worthwhile running Windows 98 Second Edition. It's not going to be very effective to be spending money upgrading a system that old past 64 megabytes. Now, what about a more modern system running Windows XP? Well, Windows XP can run in a minimum of 64 megabytes, but that's a bare minimum and just absolutely not recommended. However, 128 meg is acceptable to run Windows XP. If I have a system that has 128 megs of RAM, I can run Windows XP reasonably well on it. Of course, it works a lot better if I have 256 megabytes of RAM. There's a big performance gain going up to 256. Believe it or not, going past 256, the performance gains running Windows XP for normal tasks like web browsing, email, word processing, things like that, is very slight to almost none. Going from 256, for example, to 512, using just word processing, web browsing, and email, you're going to see virtually no performance gain. Of course, if you're doing things like Photoshop, editing large picture files, or other graphics editing movies, for example, then more memory will definitely help. In that case, I'd recommend going to 512 for most uses under Windows XP, maybe 1 gigabyte for more extreme systems, but beyond that, I'd be very cautious in recommending memory, past a gigabyte. Problem with laptops is that, while on a desktop I might say, well, go ahead, spend the money, add it can't hurt to have too much memory in a desktop system. On a laptop, it actually can hurt to have too much memory. If you have way more memory than you need, what happens is, number one, you drain the battery on your system more severely because that extra memory consumes power, and you've just shortened your battery life for perhaps no good reason. Number two, laptop systems often use the Hibernate feature built into Windows XP. That's where it can save the contents of RAM to the disk. Now, it's going to take twice as long to copy 2 gigabytes of RAM to the hard disk than it is 1 gigabyte, and it's going to take twice as long to copy that data back into memory when you open the lid and resume the system. So if you use the Hibernate and Resume from Hibernation feature, which I happen to use quite a bit, you're going to make that take twice as long by unnecessarily going up to, say, 2 gigabytes. In other words, just because my laptop might support 2 gigabytes of memory doesn't mean it's worthwhile to install 2 gigabytes of memory. Whereas on a desktop system, I might be more indiscriminate and say, well, if I could afford it, it certainly can't hurt. On a laptop system, it can. So generally, I stick with recommending anywhere from 512 meg to 1 gig in most laptop systems. That's a good amount. Of course, when Windows Vista comes out next year, that's going to up the memory requirements, and then maybe we will talk about going from the 1 gig to 2 gig. Of course, hopefully then we'll have newer, faster laptops with dual-core processors and things like that, which will really boost the performance. Okay, so now we've talked about the different types of memory. We've talked about what's reasonable to have as far as an amount of memory. Now let's see how we would actually perform memory installation or upgrade in a system. Now this happens to be a Pentium 4 laptop I have here. And I know this system currently has a 256 megabytes of PC 2100 DDR SDRAM. PC 2100. So that's the requirement for the system. Now, if I'm going to buy the memory, I go to, let's say, newegg.com, and I'm shopping for memory, and I see, oh, we've got PC 2100, but we also have PC 2700 and PC 3200, and they're all about the same price, within a few dollars of each other. Again, I might go for the PC 2700 or the 3200, it really isn't going to hurt to install the faster memory. Of course, it's not going to help either. The system is still going to run that memory at the PC 2100 speed, which means 266 megahertz. So even though the memory I'm buying might be rated for 400 megahertz, it's still only going to run at 266. One little advantage, though, might come out of this. If, for example, I buy this, DDR PC 3200, even though it's rated at a CAS rating of 2.5 cycles at the 400 megahertz or 3200 speed, that will drop to a 2-cycle rating at the lower speed. So in other words, buying faster memory may have an advantage as far as that CAS or CL number we were talking about before. That is, it'll effectively work at a lower number at the lower speed. So that's something, you can consider. Again, it generally doesn't hurt to put in faster memory than what's required. Now, once you've decided what you're going to do, and I've decided that I'm going to add 256 meg to this system, so I'm going to take it from 256 to 512. It's got 256 in it now, and I'm going to bring it up to 512. Now, most laptops, the way it works is when you buy the system, it comes with 2 memory sockets, and one of them will be filled. One of them will be filled, by the manufacturer when you buy it. So keep that in mind, that you generally have, one shot at this before you have to take memory out and start all over. So in other words, if I buy another 256 and put it in here, I will take the system up to 512, but I will have also filled both sockets. That is, I can't put any more in. If I wanted more than that, maybe I'll buy a 512 module and put that in and have 768 megs of RAM. Or I could buy, a gigabyte module and put that in and have even more memory. So that's something you have to consider, when you're buying the memory. That is, you really only have one free socket in most laptops when you're adding memory. So I've decided I'm going to put in another 256. I'm going to bring this up to 512, a very reasonable number when running Windows XP. And this system is only I believe, a 2.4 gigahertz Pentium 4 mobile. It's definitely not probably powerful enough to be running Windows Vista when that comes out. So I think I'll be adequate with the 512 I'm going to put in here. Now, to install the memory. Most laptops install memory via an access cover on the bottom of the system. Now, if I look on the bottom of this system, I see a couple of them. Here's what looks like a cover plate with 2 screws. Here's another cover plate with 2 screws. Here's a cover plate with 2 screws. This happens to be the battery, which just pops out by moving this little slide lever here. And this happens to be the optical drive, which has no visible screws, but via screws internally, I can take this out. This is not a modular bay drive. It's a permanently installed drive. So I've got these 3 access covers, and one of them very likely is going to allow me to add memory to the system. The memory sockets are probably underneath here. If you look, you might see an icon on one of them. Like right here is a little icon that looks like memory, so it leads me to believe that the memory will be under here. Of course, you can consult the manual for the system. That should tell you. Now, one problem is that some laptops put memory under the keyboard. Some will put one of the modules under the keyboard and one under a cover. Some may put both modules under the keyboard. That makes it a little bit more difficult to get to because you have to take the keyboard out. Now, it's not extremely difficult, but it's certainly more difficult than this nice little cover here with a couple of screws on it. So let's take this cover off and see what we have in here. Okay, once I've undone the screws holding the cover on, I can just sort of lift it off. Now, a lot of times these screws are of what they call a captive type screw, which is really nice, which means that the screw actually stays with the little cover. That means they don't get lost. There's a little special washer holding them in place. I like that. Now, if I look in here, I can see, oh, there is a module already in here, and there is a socket for a second module. So this one is nice in that both memory modules are accessible underneath the cover. I don't have to take the keyboard out to get to the other module or anything. Now, again, just because I'm adding memory, I do not have to use a matched module. Even though the module in here is PC 2100 256 meg, I could add, for example, a PC 3200 512 meg. However, do note this. many of the newer laptops have a type of memory system which can support what's called dual channel use. And what that means is that if you do install two modules that are of the same size and type, then they can both run simultaneously. It can transfer to both of them simultaneously, effectively doubling the bandwidth of the memory subsystem. So dual channel memory is something to look for. If your laptop supports dual channel memory, then you will want to make sure that you install two identical modules at a time. And that's something to keep in mind for the newest systems. This one doesn't support dual channel, so I could put in different modules if I wish. I do happen to have another module that is the same, is a direct match for this though. But even though it is, I won't get the advantages of dual channel memory use since this system doesn't support that. Now, I want to add memory to the system. In order to show how this is done, I have a little daughter board here which has a couple of memory sockets on it, and I'm going to demonstrate how these modules are installed, because this is one area where people can mess things up. You know, it's always this physical stuff. If somebody jams it in there wrong and applies too much pressure to it the wrong way, you can crack the module, or worse yet, crack the socket. And if it's built into the motherboard on the laptop like it normally is, that means you may be looking at a very expensive repair, or in fact, a repair that might be so expensive you'll just have to trash the system. So this is where it pays to know what you're doing. Now what you're going to do is you're going to take the module and you're going to line it up, line up the notch on the module with the little interference key on the socket. And then you're going to put the module in on a 45-degree angle. I'm going to press this one in here. And so the module, as you can see, is inserted in this on a 45-degree angle. Now it's not all the way in. I mean, it's all the way into the socket on a 45-degree angle, but we're not done yet. What we're going to do now is we're going to press it down, and then that will lock it into place. These little clips on either side have now locked the module in place. You want to make sure you double check that, press down on the sides, make sure the little clips have engaged, and that module is now fully seated in the socket. So that's basically how this is done. To remove a module, you simply bend these little metal spring clips to the side and allow the module to sort of pop up. It'll sort of pop up on its own back to the 45-degree angle like this, and then you can grab it and remove it from the socket. So the idea behind this 45-degree angle and pressing it down is it puts a lot of pressure on the little contact pins, and it makes for a very good, airtight, clean connection. So that's how this is going to work. So in order to upgrade the memory on this system, I'm going to use this DDR module, and I'm going to line it up with the notch. And again, it's in like at a 45-degree angle, and then I'm going to push it down until the little side latches engage. And that's basically all there is to it. I've now added a second 256 megabyte module to the system. Then to finish off the job, you simply put the cover back on and tighten the screws back up. And that's all there is to it. As you can see, on most laptops with an easy access cover like this, very easy to get to the memory. Installing the memory is very simple. The only things you could really do to mess it up are to try to put it in backwards, not have it fully pressed into the socket when you go to push it down, from the 45-degree angle to flat, or not have the side latches fully engaged. Also, sometimes I've seen people bend these side latches out too far when they're trying to remove a module and actually break them off. Some of the designs of these side latches are plastic, and if you bend them too far, they'll actually break off. These happen to be metal, which is a little bit better, but they can be damaged, so we want to be a little bit careful with that when we take out a memory module. Well, after installing the module, what I would then do is simply boot up the system, and most systems automatically recognize the additional memory. You'd want to make sure, for example, by going to right-click on the My Computer icon under Windows on the Windows desktop and take a look at the amount of memory it shows installed in the system, and make sure that corresponds to what you just added. If the memory isn't recognized, then there's either a problem with the module, or you don't have it fully seated, or something else has gone wrong, so you'll need to check it out. So As you can see, dealing with memory in a modern laptop is very simple. There's only three main kinds that we use. They all of these three types install in very much the same way. They're all in these little small outline DIMMs. They are inserted very easily, most through a easy-to-access panel on the bottom of the machine. In any case, I hope you find this helps you to be able to upgrade or repair, if necessary, to replace memory in your laptop systems. In this segment, we're going to talk about laptop hard drives. First, we're going to go over the different types of drives that are used in laptops and portable computers, covering things such as the different form factors, interfaces, and mounting methods that are used for the drives. Then we're going to demonstrate an actual upgrade or repair installation of a drive in a system. Well, let's take a look at the different types of drives that are used in laptops. There have been three main sizes of drives that have been used in laptops and other portable computers over the years. I have examples of those right here. We have 3.5-inch drives, 2.5-inch drives, and now 1.8-inch drives. The 3.5-inch drive, in fact, is today the most common size used in desktop computers. Really isn't used in laptops much anymore. In fact, really not at all. However, it is often used with laptops as an external drive, and that's something I'm going to show later. So the 3.5-inch drive is an example I have here. These are available in capacities up to right now about 500 gigabyte. That's about half a terabyte. So that's a lot of capacity. These are ideal for external USB or FireWire storage, and that's what we're going to show later. The most popular form factor or size of drive used in laptop computers today is the 2.5-inch drive, and this is an example of that. The 2.5-inch drive is used internally in most laptop systems. It can also be used externally via a USB or FireWire interface as well. Now, drives of this size are available in capacities currently up to 160 gigabytes. Lastly, we have a 1.8-inch drive here. Now, 1.8-inch drives are not used in very many laptops at all. In fact, these are only used in some of the very smallest palm-top computers, the very tiny laptops that have smaller than normal keyboards and smaller than normal screens. In fact, this type of drive is actually the most popular in portable music players such as the Apple iPod. In fact, the Apple iPod does use the 1.8-inch drive, an example of which I have here. These are currently available in capacities up to 80 gigabytes, which is actually pretty amazing considering their small size. Now, in addition to the different form factors as far as the size of the platters, there's another issue to consider. Now, since most laptops use 2.5-inch drives, like the example I have here, the issue I'm talking about is not just the overall height and width, but the thickness of the drive. 2.5-inch drives over the years have been available in a variety of thicknesses, and not all laptops will accept all of the different thicknesses. They actually started out at a whopping 19 millimeters thick. However, today, most 2.5-inch drives used in laptops are only 8.5 or 9.5 millimeters thick. Those are the most common sizes used, 9.5 actually being the most common. This, in fact, is a 9.5 millimeter thick drive. Now, what that means is that if you have an existing laptop and it currently has a drive like this in it that's 9.5 millimeters thick, you could replace it with another 9.5 millimeter or a thinner 8.5 millimeter drive. But you may not be able to put a thicker 12 millimeter or thicker drive in that system. As an example here, this is a 17 millimeter drive. You can see the difference in thickness here. This was used in a much older laptop. In fact, this older 17 millimeter drive is only 2 gigabytes in capacity, and smaller drives in the 9.5 millimeter form factor, like I have here, are available up to 160 gigabytes in capacity. So it's an incredible, amount of capacity is now available in these very thin drives, which is good because virtually all laptops today will accept the 9.5 millimeter thick drive, and that's the most common form factor as far as thickness goes for the 2.5-inch drive. So when you do consider a repair, replacement, or an upgrade for an existing system, try to find out how thick the current drive is in the system. You can always put a thinner one in, but you generally won't be able to put a thicker one in unless the system has room for it, and you'll have to check that. Another issue to discuss with laptop drives is the electrical interface. Now, most laptop drives, 2.5-inch form factor especially, use what we call the parallel ATA interface. The ATA stands for AT attachment. Now, the parallel ATA interface uses, normally in desktop drives, uses a 40-pin or a 40-conductor ribbon cable like this. And we have a 40-pin connector on the back of the drive. Well, that size of connector is too large to fit on the smaller laptop 2.5-inch drives. So what they did was they shrunk the size of the connector down and included power pins as some of the pins. So what we end up with is kind of a 50-pin unitized connector that includes power pins as well. There are adapters. For example, this is an adapter that can be used to install a laptop 2.5-inch drive with its 50-pin connector and adapt it to the standard 40-pin connector with separate power cable used on desktop drives. So with something like this, it can be plugged into the laptop drive like so, and then I can plug a standard ribbon cable into this connector and a standard power connector as well. So this is useful for mounting a 2.5-inch drive temporarily in a desktop system. Now, I've done that many times to perform data recovery on a drive like this, or in some cases to pre-format the drive, pre-install software, operating systems, things like that. Then, with everything installed, it can be mounted in the laptop system with everything already on it. So these types of connectors or adapters are very useful. Now, serial ATA is an interface that's used in a lot of desktop drives these days. As you can see, serial ATA uses a much thinner cable than the ribbon cable commonly used with parallel ATA. The serial ATA cable has only 7 conductors on it instead of the 40 or 80 conductors found in the parallel ATA ribbon cables. Now, there are 2.5-inch drives that use the serial ATA format, but there are not very many laptops will accept that type of interface internally. The new 900 series chipsets from Intel do support serial ATA, but in fact in many of those systems they use a serial to parallel converter chip because parallel ATA drives are still far more plentiful in the 2.5-inch form factor. Whereas in desktop systems, we see the serial ATA is already surpassing parallel ATA in new installations. In laptops, we're still predominantly using the parallel ATA interface, and that may continue for another year or so. I do expect the serial ATA interface, however, to take off and eventually become as a replacement for parallel ATA drives, just as it did with desktop systems, or is happening with desktop systems, I should say. Okay, another thing I wanted to mention was external drives. You know, both the 3.5 and the 2.5-inch drives can be mounted in external enclosures and be used for, especially for backup or for just larger capacity offline storage. Here's an example of that. This is a 3.5-inch drive mounted in an external enclosure, and this one supports USB. And here's a 2.5-inch drive mounted in an external enclosure. Obviously, the 2.5-inch in the enclosure is much smaller. This one can also be powered directly via the USB interface, either directly via the interface plugged in or via a second USB connection that plugs into a power connector here. Now, this can be ideal for backup that you take with you if you travel. For example, when I travel, I would take a drive like this as a backup with me, and then as I'm working on the road, I could copy data to this drive and be backed up. Also, in the case of my main drive failing, in some cases I could have an image of the partition of my main drive and be able to simply swap the drive from here into my main system and be back up and running very quickly. External drives in the 3.5-inch form factor, like this larger one here, their advantage is huge capacity. Since we can buy drives in this size that store up to 500 gigabytes or more, we can put a lot of data, huge music collections or other information on a drive like this that would not fit normally on a 2.5-inch drive. So keep external drives in mind for use with laptops. Now, another interesting option available for some laptop models is a bay mounted drive. Now, some laptops use what we call a modular bay, where you can install different drives, like usually optical drives like CD-ROM, DVD, burner drives, floppy drives, second batteries are available to fit in those bays. And here's an example from IBM where they have a bay device which basically allows me to install a second hard drive and then simply slide it in and install the drive, in fact, live while the system is running. It's hot swappable. So that makes backups, for example, really easy. I can simply pop the drive into this bay device, slide it into the modular bay, and in seconds it becomes active and ready within Windows, and then I can do a copy of all of the data from my main drive to this drive, a full backup of the entire drive in only an hour or so at full ATA drive speeds. And then once that's done, I can take the drive out, and then should my main drive ever fail, I've got a fully ready-to-go backup with the full image of my system on it that can be taken out of here, installed in the laptop directly, and I'd be up and running in a matter of minutes. So something like this is very useful for backup, also just for having a large amount of secondary storage that you can pop in at a moment's notice. This is, however, only available generally for laptops that have modular bay drives. Okay. Now what I wanted to do was take a look at how you would actually install or upgrade a drive in a laptop. Now I actually have a laptop here, and I'd like to upgrade the drive in it, or perhaps the drive that's in here has failed and I'd like to replace it. I should say virtually all hard drives in all laptops are replaceable, and they virtually all use industry standard form factor drives. So that means that we have an easy upgrade or repair replacement, and we don't have to go back to the original manufacturer of the laptop. Doesn't matter who made this system, I can buy a drive from anywhere and install it. The only unique things you'll find as far as hard drives go in the laptops is that oftentimes the drive will have some sort of a custom bracket attached to it, and that will have to be transferred over to the new drive. Now, where is the hard drive in your laptop? Well, it can be several places. I would say the most common placement for drives is accessible via the bottom of the system here. It'll be through one of the access panels on the base of the system. For example, just like memory is generally accessible via an access panel, so will usually the hard drive. If it's not available or accessible via an access panel on the bottom, it may be accessible under the keyboard. That's another common placement. So that does mean you have to generally remove the keyboard in order to get to the drive underneath. It is a little bit more difficult, but not terribly difficult in that case. Now, some laptops were designed for very quick and easy replacement of drives. For example, some of the IBM and Toshiba models use caddies like this. So once the drive is mounted in a caddy, an access door can be simply flipped open, and in this case, it even had a handle on it. You could grab the drive by the handle, pull it out, and take a second drive, for example, in another one of these caddies and slide it right back in. So it would be possible, for example, to have several drives with different operating systems or different images on them, and in a matter of seconds, with no tools, pull the one drive out and slide the other one in. These caddy systems, though, are somewhat expensive. For example, just even buying a caddy like this with no drive was often somewhere between $50 and $100. That's more than the cost of the drive in some cases. So the majority of laptops don't use caddies like this. They have some sort of a simple bracket that will be attached to the drive that you'll have to transfer over to the new drive, and tools will be required to remove the drive. It won't be just some slide in and out type item. But be aware that some laptops do use caddies, and if yours does, you'll either have to transfer the existing drive over into the, I should say, transfer your new drive into the existing drive's caddy, taking the existing drive out of it, or somehow purchase an additional caddy. Now, in some cases, companies like IBM didn't make the caddies available as a separate purchase item. They only sold them with one of their drives installed. However, aftermarket companies, third-party companies, did make the caddies available, so in that case you could purchase it from them. Well, let's take a look at actually upgrading the drive in this system. Now, as I mentioned, this one does have the drive accessible via an access panel. It happens to be right here. And there's one screw right here that I need to remove in order to gain access to the drive. So that's what I'm going to do right now. I'm going to remove this screw. And with the screw out, I can simply pry out this little access panel here, take it out, and now you can clearly see the hard drive on the inside. Now this one, to remove it, I simply grab it by this little plastic tab here and lift up, and then slide the drive out. It's that easy and quick to remove the hard drive in most laptops. Now, if I was going to be replacing this drive with a larger one, what I would do is simply undo the 4 screws holding this metal bracket on. We've got 2 here, and we've got 2 on the other side. And then I would take this bracket and literally transfer it over to my new drive. And the new drive would then be installed with the bracket back in the system in a matter of seconds. So let's say I took this bracket off. I'm not actually going to do it here, but it would be no problem to do that in just a few minutes. Transfer the bracket and screws to the new drive. Then you could take the new drive with the bracket and simply reinsert it into the machine. And in this one, it goes something like this. Simply line it up with the connector, and then give it a little push to insert. And now it's nothing more than a matter of putting the access cover back on and securing it with the screw. And that's it. Now that drive that I just put in there could have been a 160 gigabyte drive. The original drive in the system may be only 10, 20, or 30 gigabytes, so it's very easy and quick to replace a drive with something considerably larger. Of course, after installing a drive like this, you would then have to partition and format the drive, install your operating system, etc. But that wouldn't be very difficult, especially if you had a backup of your existing system on an external drive like this. So once you had your external drive connected, your backup on it, you could then restore that backup to the new drive that you just installed. So it's very easy to take an existing system and upgrade the capacity of the hard drive. It does the longest part would in fact be copying the data from your drive to an external drive and then back to the new drive. One tip I wanted to add about using external drives with your laptop is that it's often much less expensive to make your own external drives than to buy them pre-bought. What I mean is this. With both the 2.5 and the 3.5 inch drives, what you can do is buy the raw drive and buy a raw enclosure and simply put them together yourself. Most of these are very simple to assemble. For example, in this 2.5 inch enclosure, you simply mount a normal 2.5 inch drive in the enclosure, plug it into the connector. The little circuit board inside here converts the parallel ATA to USB or FireWire, or both, depending upon which type of enclosure you buy. And then simply close it all up, and you've now made your own external USB or FireWire drive. I've often saved a lot of money by making my own, buying my own enclosures and my own drives. I can do that also with 3.5 inch drives. In fact, this is one that I assembled myself. I simply bought a drive, bought the enclosure. These enclosures are only $20 to $30. They're very inexpensive. And then take any drive and mount it inside, and you can make your own external drive. These are ideal for backups, for transferring data from one system to another, a very high-speed connection using USB or FireWire to your system. So I hope you've found this section on hard drives very informative, and you'll be able to now repair, replace, or upgrade any of the drives in your laptops. In this segment, we're going to talk about laptop optical drives. Now, the optical drive in a laptop is one of the more overlooked items for repair, replacement, or upgrade. And in actuality, there is a lot of standardization in the form factor and interface with the optical drives, and you'd be surprised at how many of them can be easily replaced in most laptop systems. So in this segment, we're going to take a look at the different types of optical drives that are available, different form factors, interfaces, things like that. And then we'll actually be performing an upgrade of the optical drive in this particular laptop model. Now, optical drives are available in a number of different types. First, let's look at the different types of disks that they handle. We have drives which were just CD-ROM drives originally. Then came CD-ROM and DVD combination drives. Well, any DVD-ROM drive can also read CDs. Then we had what we called combo burners. That is, it was a DVD-ROM reader, but it could burn CDs. A DVD-ROM CDRW drive is what we called that. That was very popular. In fact, that's what's in this particular laptop, a DVD-ROM CDRW burner. Then we had DVD burners. And those are the newest types of drives that are available. Now, a DVD burner can be a single-layer burner, or the latest ones are actually dual-layer burners. That is, they can burn dual-layer disks. And that's what I have an example of here. I have a DVD dual-layer burner. And this drive is also not only more capable of reading and writing more different optical disc formats, but it's also faster than the drive that's in the system. Now, in addition, we also can talk about internal versus external drives. Now, the internal drives are usually what we call a slimline form factor like this. As you can see, this drive is very, very slim. It's got a kind of a little extra shape, a little angular shape to the side here. It also uses what has become an industry standard connector. It's not something you normally see on hard disks, but this is a form of parallel ATA connection. That's how these drives interface to the system normally. I do expect to see serial ATA versions coming online in the next year or so, but so far, almost all optical drives in laptops are parallel ATA. The size and shape of the bezel or faceplate here is also somewhat of a standard. And that means that this drive will generally be replaceable in most laptops. Now, external optical drives are usually of a much larger form factor like this. This is an example of a typical 5¼ external optical drive. And this one also uses parallel ATA, but a very different connector than what we saw in the slimline drive. This is your normal standard 40-pin parallel ATA connector into which we would plug a ribbon cable. Well, this type of drive you're not going to be installing internally in any laptop. You'll need a slimline drive for that. Now, some laptops use modular bay drives. This is an example of a modular bay drive. Now, what you'll see if you look at this carefully is really all this is a slimline drive like this with some custom bracketry attached. We have a custom bracket on the back, for example, that modifies the cable connector. So we have a connector that looks like this instead of the one over here, which looks different. Now that's courtesy of really just this bracket that's mounted to the back. I could take the bracket off of this bay drive and move it over to this new replacement drive. Same for the side brackets. We'll usually have side brackets, a back bracket. The only problem with a lot of these bay drives is that they'll have custom faceplates, and the faceplate can be a problem. For example, this one has sort of an angular shape to it, a sloped shape, plus it has a notch cut out of it here, and this drive doesn't. Now, what I could end up doing is if I was going to use this drive as a replacement, I'd have to actually file this little plastic bezel here, file a notch into it. It might look a little bit crude, and it wouldn't have the nice angled front, so it wouldn't match the exterior of the case perfectly. But I could use this drive as a replacement for this one by swapping all the brackets over and filing that notch. So with a little creativity, you'd be surprised what you can do with replacements. Now, this drive that's in the modular bay happens to be a Panasonic drive, and this one happens to be an NEC drive. If I could have found a Panasonic drive that was like the DVD dual layer, for example, it would most likely accept this faceplate, and in that case I could transfer the bezel or faceplate from the old drive to the new one, and then really completing the upgrade and making it look as if it was the same original drive that was in there. But that depends on things like the button being in the same place, the eject hole being in the same place, the LED being in the same place, and unfortunately there aren't really standards for that. So it's not usually possible to swap faceplates among different manufacturers' drives. For that you'll need not only the same manufacturer's drive, but oftentimes the same, like model line. Sometimes even between the same manufacturer they'll change things like the position of the button and LED and eject hole and things like that. So that's where the laptop drive replacement kind of has some difficulties with the slimline drives. The faceplates don't always match up, and you may have to end up doing some filing or modifications in that case. Okay. The other thing I wanted to mention was external drives. I like to connect external drives to my laptop when I'm working at home base. And the main reason for that is that, first of all, the external drives are a lot faster than the internal drives. Drives like this are available up to 16x dual layer burners. This type of a drive, the Slimline, is only available up to a 4 or possibly 8x dual layer burner, about half the speed. So you can get a lot more performance in the full-size drives here. Also, the full-size drives are cheaper. They can be sometimes half the cost of the Slimline drive. In general, if I'm working at home base, I like to attach an external USB or FireWire drive like this and save the internal drive. Optical drives are kind of a wear item. They do tend to fail the more you use them, and they take a lot of abuse. So I try to preserve the original or the built-in Slimline drive in the laptop by using an external drive for most of my burning, CD ripping, or other types of activities with backing up, creating backup disks. I try to use the external drive for that because I'd rather put wear and tear on a cheap, easily replaceable external USB drive than the more expensive Slimline internal. But if you ever do have problems with that internal drive, we generally can replace it, and that's what we're going to be doing here. Now, as I mentioned in the section we did on hard disks, when using external drives, I like to build my own. It's cheaper for me to buy an external drive like this, just a raw 5 1/4 inch drive, and then buy an empty enclosure and put them together myself. For example, this is one that I just built a few days ago. It's just a generic external dual layer DVD burner and a fairly inexpensive external enclosure, and this one supports both USB and FireWire. So now I can connect this to any laptop or desktop system and use it as an external burner and save wear and tear on the more expensive internal drive. So I'm a big fan of the external USB and FireWire drives for not only their greater performance, but saving wear and tear on the internals. All right, well now, how are we going to replace the drive in a laptop like this? Now, this laptop has a built-in DVD-ROM CD burner, but this is not a modular type. In other words, this drive doesn't slide out in a modular basis like the example I was showing you here. So how are we going to get this drive out, and can we, in fact, even replace it? Well, the answer is yes. In fact, as sort of a quirk of the way things work, in general, the non-modular sort of built-in drives are in some cases easier to replace or upgrade than the modular bay drives because they have usually less strange face plates and things like that. So this drive is actually going to be very easy to replace. Let's see how we would do it. Well, the actual physical attachment method may vary from laptop to laptop. Basically, you're going to look around for screws near the perimeter of the drive. For example, if I hold this replacement up here to this, you can see kind of the basic shape, and it kind of leads me to believe that one of the screws, maybe this screw here, is what's holding it in. A lot of times there'll be little brackets attached to the drive, and there'll be a screw then attached to that. So in fact, on this laptop, in order to replace the drive, it's this screw that has to come out. So I'm going to take that drive, take that screw out. And set it to the side. And now I should be able to slide this drive out. As you can see, the drive is, again, one of these slimline drives, except it has some additional bracketry attached. I can see, for example, there's this black bracket that's attached to the bottom of the drive. I also see that there is a little metal bracket attached to the back here, and that's what is where the screw went through that held it in place. So in order to install my new dual layer burner into this laptop, I'll need to simply transfer the bracketry over. By the way, you can see on this particular laptop, the hard drive was mounted right underneath the optical drive. So if I wanted to upgrade the hard drive on this system, you know, this would be a perfect opportunity to do that as well. It's right there, easy to get to. Well, in order to replace the optical drive, I need to take these brackets off. So I'm going to do that right now by removing the screws that are on the side holding the bracket in place. There's going to be 4 of them. This last one, I'm going to have to use a different screwdriver because it's very recessed. My power tool won't reach in there. Now I've got all of the screws off of the bracket, and the drive should simply come away from the bracket. At this point, I've only got the little back bracket on the back here to take off, so I'm going to do that now. Okay, now I'm going to transfer this little back bracket to the new drive. Now line it up, transfer it to the same holes on the new drive. And let me get the screws ready for that. Now that the little back bracket is attached, I can attach the main bracket. And that one is going to go like so. You see the drive just sits in the bracket, and now I'll simply install the screws just as they were on the original drive. For the last screw here, I'm going to have to use this manual screwdriver because it's in the recessed hole here. And there we have it. So now all of the bracketry has been removed from the original drive and attached to the new drive. Now all I have to do is simply slide the new drive into place, just as the original drive was in there, and add the remaining screw that holds it in. And there we have it. Now the new drive is installed. Now, again, one of the things, one of the quirks with this is a lot of times you're not going to have a perfect match on the faceplate. You'll notice that this original drive had sort of an angled or beveled faceplate on it, which kind of matched the angled front part of the case. And the new drive just has a flat bezel, which doesn't quite match. So it looks a little bit out of place, but not too bad. And the main thing is that it plugs in and it physically and electrically works. And, of course, that it's a much faster drive and a dual-layer DVD burner. So whether this drive still worked and was simply being upgraded, or it had failed and we were replacing it, as you can see, doing either a repair replacement or an upgrade of an optical drive on a laptop is something that's not very difficult and can be done in just a matter of a few minutes. In this segment, I want to talk about some of the most common failures that happen with laptops and how they can be very easily repaired. Now, two of the most common problems I've seen with laptops over the years are, number one, a failure of the inverter that drives the backlight for the LCD, and number two, failures of the keyboard. Now, the keyboard is easy to understand because that's something you're constantly typing on, touching. People spill things on it, drop things on it, etc. So we'll get to that as a second item. First thing I want to talk about, though, is the LCD backlight. Now, what I'm talking about here is inside of the LCD, the liquid crystal display, there is a cold cathode fluorescent tube, basically a little fluorescent bulb, and that's what provides the light behind the LCD. Now, this tube is driven by a high voltage inverter circuit, and this circuit, because of its high voltage nature and its sometimes high temperature operation, is somewhat stressed and often fails. Now, the symptom of an inverter failure is when the backlight simply disappears. In other words, the screen is dark. Now, the scenario I'm talking about is where the LCD screen is completely dark, but if you plug an external monitor in, you can see, everything on the display just fine. So an external monitor works, your built-in LCD does not. Now, if you shine a very bright light at the LCD, sometimes you can actually see what's going on, on the display. That's another tip. So if you suspect a backlight failure, what you should do is, number one, connect an external display. If the external display works, then you know your display circuitry is fine. There's just something wrong with the LCD. Then shine a bright light, like a high-powered flashlight, right on the screen. If you can see the text and Windows icons and other things on the screen, by shining a bright light on it, then what we can tell there is that the liquid crystal portion is actually working. We just don't have any light coming through it. And that usually indicates a failure of the backlight. Now, the backlight itself can actually fail. That is, the bulb can break or burn out. But also, more common, what I see is the failure of this inverter circuit that drives the backlight. Let's take a look at that. Now, in order to repair that type of situation, you have to remove the LCD from the system. Now, typically what that means is that you're going to disassemble the machine to where you take the liquid crystal display off of the system by where it connects at the hinges. So that's what I've done here. This is one of the displays, or a display that has been removed from a laptop, and you can see I basically just undid the screws where the hinges attached the display to the laptop. Now, in order to get to those screws, you typically have to take out the keyboard and possibly a few other items on the very top of the laptop, and then you'll usually be able to get to these screws and disengage the display. There'll be a couple of connectors in some cases to unplug, and usually the whole display then simply separates from the system. Now, once you've got the display separate from the system, what you then need to do is to remove all the plastic, bezel and plastic surrounding the LCD in order to really get to it. Now, in order to do that, most laptops will hide screws that hold these plastic pieces together. And how they'll hide them is basically with some tape that's the same color as the plastic on the body. Now what you'll see here on this one, for example, is some small little round pieces of tape. I'm going to pry one of those off, and they have glue on them. And what I'm going to do is I'm going to stick it to a plastic bag here. And what that'll do is preserve the glue, so when I go to reuse it, it'll be available. So there you can see this little black circle of tape that has glue on it that basically covers the screw. It's just a cosmetic cover. I mean, if it's just your system and you don't care how it looks, you could, of course, leave these little black covers or whatever color covers off, and you'll just see the screws. So, for example, on this display, there was one here, there's one over here, here, and here. Sometimes they'll also be on the side or possibly even the back of the display as well. And once all of those are taken off, you can then pry the plastic apart and get to the actual internal components of the LCD. Now here I've got one where I have taken the internal LCD out. So this is the actual liquid crystal panel. Now, in some of these, if you turn the panel around, you'll be able to see the actual fluorescent tube that is the backlight. Now, this one is internal and really not replaceable. In some cases, that bulb is separately replaceable. Now, where you'll want to replace the bulb, or where the bulb will be causing a problem, is sometimes when you'll notice the LCD on a laptop is kind of dim, it's not getting as bright as it used to, or especially it's like very reddish tinged. A lot of times this will happen when you first turn it on. It'll be a very sort of a red or pinkish color, and then eventually as the bulb warms up, it'll turn to more normal colors. Well, that kind of means that the actual bulb is going bad, not the inverter. So in that case, you'll either have to try to replace that bulb or possibly the entire LCD if it's a non-replaceable bulb like this one. Well, when the inverter circuit fails, usually this backlight goes out completely. It doesn't just fade away, it just simply stops operating. Now, the inverter is this high voltage transformer circuit board that you usually find associated with the display connected to the backlight bulb, and that's what we see here. Usually we'll have a couple of connections to it. One is this little thin ribbon flex cable, and the other is the high voltage connector to the actual bulb. And you'll notice on these inverters that they'll usually have some kind of a warning, danger, high voltage. And while the system is running, yes, you can get quite a shock from touching this. So you definitely don't want to be touching these inverters while the laptop is running, because there's literally thousands of volts present here. So in order to replace the inverter, you simply then unplug it. Now, this one uses a small flex cable, which I simply pull away, and then another connector for the actual backlight. So this is what amounts to the inverter circuit for this LCD. And usually they're about this size. Some might be a little bit smaller, some a little bit larger. And they're usually a thin, long board like this. You can contact the original manufacturer of the laptop itself, or possibly even the display. For example, this is a Hitachi display, and it happened to have been in a compact laptop. So we could maybe see if we could get an inverter from Hitachi. Sometimes these inverters will have their own part numbers on them. You can try to look that up via a search on the internet. But your best bet is to contact the manufacturer of the laptop. A lot of times these inverters will sell anywhere from, let's say, around $20 to $100 or so. And as you can see, it's just a couple of connectors to fairly easily replace. So once I've removed the bad one, I can then take the good one, reconnect the cables, like the ribbon flex cable here, and then the cable to the actual bulb. And then, of course, comes the harder part, which is actually putting this entire LCD panel back into the plastic and then attaching the whole hinged assembly back onto the main system. And then connecting, of course, the main ribbon cable from the LCD to the motherboard. I've actually had these inverter circuits fail on several laptops, and it seems to be a fairly common item because, again, it seems to be high stressed, high voltage, has some temperature issues and that sort of thing. So if you have the symptoms, as I described before, where the light simply goes out on the LCD, you may not have to replace the entire expensive LCD panel. It may be something as simple as a $25 or so inverter board. So that's a common failure and one that's very easy to repair on most laptops. Now, the other common failure I see is with keyboards. You know, sometimes the keys will get stuck. Sometimes keys will be pried off the keyboard and lost or damaged. For example, here we have a perfectly good, actually a very nice Pentium 4 laptop, and it has now become unusable because at least one of the keys is missing. And in most cases, you cannot purchase individual keycaps separately. And in this particular example, not just the keycap is missing, but the entire structure underneath the keycap that allows it to move up and down, and the basic mechanism has also been damaged or missing. So it's more than just the keycap itself that's missing from this particular laptop. So we now have a laptop that's relatively useless. Well, we could, of course, plug in an external keyboard and use it that way, but then it's not quite so portable anymore. So what I'd like to do is to replace this keyboard. Now, in most cases, you can buy replacement keyboards for most laptop models that are, you know, in the last 5 years or so for anywhere from $50 to $100 or so. In fact, the keyboard replacement for this particular laptop cost $60 and was, you know, fairly easy to order. You could order it from either from the original manufacturer or from one of the many vendors of laptop parts that you can find on the internet. And once the keyboard is ordered, then it's usually a simple matter to replace it. And that's what we're going to do here, is actually demonstrate replacing the keyboard and therefore repairing this laptop. I have my replacement keyboard here. This is what it looks like. Brand new keyboard. It has a ribbon cable, what we call a flex cable, which is a kind of a ribbon cable that connects it to the motherboard. And basically it's attached with 2 screws, and very, very easy to install, or fairly easy to install. So let's take a look at how that would be done. Now, in most laptops, in order to replace the keyboard, you'll need to remove this plastic panel that is above the keyboard. It's kind of between the keyboard and the base of the LCD screen. Now, these plastic panels are basically just snapped into place, and to remove them you have to unsnap them, kind of pry them out, and that is the little bit tricky part here. If you've never done it before, it almost seems like you're going to break this plastic piece. In fact, I have broken a few of them, so in some cases it might be good to buy one of these plastic pieces along with the keyboard, but after you've done it a few times, usually you can get them off without doing any damage. Now, how do you pry that out? Well, I tend to use you know, very small jeweler's screwdrivers, but sometimes they can also mar other parts of the case depending upon where you're prying. You want to be careful. If you're working on a system that's not yours, you don't want to leave you know, screwdriver gouges all over the plastic case. What I use sometimes actually are what I like to call trim sticks. Basically, these are small little pieces of wood with an angled edge, and these are sold actually for I think doing like nails and that. They're sold in you know, grocery stores and things like that, drugstores. And these trim sticks can be used, because they're wood, they can be used to pry things without marring or scarring up the plastic body of the laptop. So in some cases, these can prove to, you know, be a useful tool. Well, what I'm going to do is I'm going to use the screwdriver here, and I'm going to start at this end and simply pry this little bit of plastic away. And notice once I've got it away a little bit, I can kind of begin to work it away from the system, kind of without breaking it. And there, as you can see, it's come off, and none of the plastic tabs have been broken. And now I have access to the screws which hold the keyboard in place. So again, most laptops will have some sort of a trim piece like this that literally snaps into place that you have to pry off in order to get to the screws that are holding the keyboard in place. Now, the screws on this system holding the keyboard in place happen to be right here and right here. By the way, also, for example, since we were just talking about the LCD, the hinge screws are right accessible in this area as well. Well, I'm going to be taking out the keyboard, so let's do that. Let me get to these screws. And only 2 screws are generally used to hold the keyboard in place. Once the two screws are removed, you can lift the keyboard up the back here and then slide it forward and disengage it from the laptop. Well, it's still connected via the ribbon cable here, but as you can see physically it is disengaged. So now what I need to do is to unplug the ribbon cable from the connector. Now these flex cables, they have a variety of different ways that they're actually attached. Most of these bigger ones like this will have some sort of a lock holding them into place. And what I need, again, is a very small jeweler's screwdriver. And I need to lift up on the little plastic locks that are holding the ribbon cable in place. And there's one usually on either side. Once those are lifted up, I can then pull the ribbon cable, slide it right out of the connector. As you can see, it's come out there. So now this keyboard can be set aside. By the way, if you don't have a service or parts manual for your laptop, and unfortunately most laptop manufacturers don't make the service and parts manuals available, then what you can do is if I needed to, or I should say, for example, when I needed to find this particular keyboard, I didn't know what part number it was. I actually took it out, flipped it over, and usually you'll find some part number information right on it. And all I did basically was a Google search on the internet using the part number I found here, and I hit upon 5 or 10 different places selling this keyboard. And it was a lot cheaper to buy the keyboard through some of these aftermarket places than it was through the actual manufacturer of the system, in this case Toshiba. So that was how I was able to find the keyboard for a relatively inexpensive price. And now these keyboards are generally not interchangeable between laptop manufacturers. I mean, Toshiba may have used the same keyboard on a number of different models, but in most cases, you know, a keyboard from a Toshiba isn't going to work in a Compaq, which isn't going to work in an IBM, you know, which isn't going to work in a Dell, and so on and so forth. You need to find the exact keyboard for your particular model. So once we have the replacement keyboard here, the reinstallation is just the opposite of how we took it out. First thing I'm going to do is I'm going to start by sliding this little ribbon cable into its connector. And you kind of want to make sure it's fully seated in that connector. And then, once it is, whoops. Okay, you slide the ribbon cable into place and then use the small screwdrivers to push these little tabs down to lock it into place. So now the ribbon cable is locked into place. So now you can fold it underneath the keyboard, just as the original was, and then engage these tabs in the body of the laptop and set the keyboard down. And at this point, all I have to do now is to put the 2 screws back in that are holding the keyboard in place. And I'll do that. And once I've got the 2 screws holding the keyboard back in place, I can then snap the plastic trim cover back in place. Now before you actually do that, it might be a good idea to power the system on, to check the keyboard and make sure it works. I know this one works, so I'm going to snap this cover back in place. Now you just basically start it either in the middle or at one end and kind of work your way across, pressing it down into place. And once this trim piece is snapped into place, that's basically it. As you can see, it's not very difficult to replace a keyboard. So, in this segment, we've covered or at least two of what I have found to be some of the more common failure items in a laptop. We talked about replacing the inverter circuit, which drives the backlight, and of course a keyboard replacement. Now this laptop with a brand new keyboard is ready for another year or more, couple years of useful life.